1.3 First sum. A vessel in the form of hemispherical bowl mounted by a hollow cylinder. The diameter is 14 centimeter and height of the vessel is 13 centimeter. Find the capacity of vessel. Capacity of vessel is nothing but the sum of volume of cylinder and volume of hemisphere. First we have to find the volume of cylinder. Volume of cylinder formula pi r squared into h. Here r value, diameter 14 centimeter, then radius is half of the diameter 7 centimeter, here also 7 centimeter. The radius of cylinder is 7 centimeter. Next we have to find the height of the cylinder. The total height of the vessel is 13 centimeter. Here the radius is 7 centimeter. The remaining part is the height of the cylinder. So we have to subtract 13 minus 7. Then we get the height of the cylinder. 6 is the height of the cylinder. Volume of cylinder is equal to pi value 22 divided by 7 into r squared is 7 into 7 into h value is 6. 7 get cancelled. 22 into 7 6 are 42. 42 into 22. 42 into 22. 2 2s are 4. 4 2s are 8. Again 84. 4 12 9. 924 centimeter cube is the volume of cylinder. Next we have to find the volume of hemisphere. Formula 2 pi 3 pi r cube. Here r value is 7 centimeter from this diagram. 2 by 3 into pi value 22 divided by 7, r value is 7 cube. 7 into 7 into 7. 7 get cancelled. 2 into 22 44. 7 into 7 49 divided by 3. 49 into 44. 9 4s are 36. Remaining 3. 4 4s are 16 plus 3 19. Again 1 9 6 6 15, remaining 1 21. 2 1 5 6 divided by 3. 2 1 5 6 divided by 3. 7 times 21. 1 time 3. Remaining 2. 8 times 24. Remaining 2. 6 times 18, remaining 2. 6 times 18, remaining 2. 6 6's go on. So we have to round off this value as 0.67. Volume of hemisphere is equal to 718.67 centimeter cube. By adding these values we can get the capacity of vessel. 924 plus 718.67 centimeter cube. 924 plus 718.67. 67. 4 plus 8 12. Remaining 1 4 16. 1642.67 centimeter cube is the capacity of vessel. Second problem. Northern and engineering students was asked to make a model shaped like a cylinder with two cones. The model is like a cylinder with two cones attached its two ends. The diameter of the model is 3 centimeter. Diameter 3 centimeter and its length is, the total length is 12 centimeter. If each cone has height of 2 centimeter, cone height is 2 centimeter, find the volume of the model that Northern made. From this diagram, the height of the cone is 2, radius r is equal to 3 divided by 2 because the diameter is 3. Radius is nothing but the half of the diameter. The total height, the total length is nothing but the height of the model is 12. Up to this part the height is 2. Here the height is 2. The remaining part is the height of the cylinder. Height of the cylinder is equal to 12 minus 2 minus 2. We get 8 centimeter is the height of the cylinder. In this question, we have to find the volume of the model. Volume of the model is equal to volume of the cylinder plus volume of the cones. Volume of the cylinder, here the radius is 3 by 2, height of the cylinder is 8 centimeter. Volume of the cylinder formula, V is equal to pi r squared into h. Next one, the volume of the cone, here the radius is 3 by 2, the height of the cone, each cone height is 2 centimeter. Volume of the cone 1 by 3 pi r squared h. Now we are finding the volume of the model. Here we substituting these values. V is equal to pi into r value is 3 by 2 into 3 by 2 into height 8 centimeter. In 2 tables 4 times, again 2 tables 2 times. Pi into 3 into 3 into 2. 3 3s are 9, 9 2s are 18 pi centimeter cube is the volume of the cylinder. Next one, volume of the cone. V is equal to 1 by 3 pi into r square 3 by 2 into 3 by 2 into height 2 centimeter. 3 3 get cancelled, 2 2 cancelled. V is equal to pi into 3 divided by 2. V is equal to 3 pi divided by 2 is volume of one cone. But we have to find the volume of two cones. 2 into volume of one cone is equal to 2 into 3 by divided by 2. 2 2 cancelled, remaining 3 pi. Centimeter cube is the volume of two cones. Next, volume of the model. Volume of the model is the sum of volume of the cylinder and volume of the cone. By adding these two values, 8 pi centimeter cube plus 21 centimeter cube, we get 18 centimeter cube plus 3 centimeter cube, we get 21 pi centimeter cube. Applying pi value 22 divided by 7 into centimeter cube. In 7 tables 21 is 3 times. 3 into 22 centimeter cube is equal to 66 centimeter cube is the volume of the model. Third sum, from a solid cylinder whose height is 2.4 centimeter. Height of the cylinder is 2.4 centimeter and diameter is 1.4 centimeter. Diameter 1.4 means radius is half of the diameter is equal to 0.7 centimeter. Here the radius is 0.7 centimeter. A cone of same height and same diameter is curved out. A cone of same diameter and same height is curved out. Find the volume of the remaining solid to the nearest centimeter cube. Now we are finding the remaining part. Volume of the remaining part. Okay. Volume of the solid is equal to volume of the remaining solid is equal to volume of the cylinder minus volume of the cone. Volume of the cylinder formula V is equal to pi into R squared into H. Volume of the cone formula V is equal to 1 by 3 pi R squared into H. Volume of the remaining solid is equal to volume of cylinder minus volume of the cone. Pi R squared H and pi R squared H both terms contains. So we take out the pi R squared out, H is outside. The remaining one is here 1 by 3 equal to pi R squared H into 1 minus 1 by 3. 1 minus 1 by 3. Here we are multiplied and divide by 3 on numerator and denominator. We get 3 by 3 minus 1 by 3. 3 minus 1 divided by 3 is equal to 2 by 3. So 1 minus 1 by 3 value is 2 by 3. Pi value 22 divided by 7. R value 0.7 into 0.7. Height 2.4. We can write 0.7 as 7 by 10 as well as 2.4 as 2 by 10. 22 divided by 7 into 7 by 10 into 7 by 10 into 24 divided by 10. 7 get cancelled. 7 cancelled. 3 tables, it is 8 times cancelled. Remaining 22 into 7 into 8 into 2 divided by 1000. 22 into 2, 44 into 7 8s are 56 divided by 1000. 56 into 44. 6 4s are 24, remaining 2. 5 4s are 20, 20 plus 2, 22. Here also 224. 2 6 4 2. 2 4 6 4 divided by 1000. The volume of the remaining solid V is equal to 2464 divided by 1000. Divided by 1000 we get 2.464 centimeter cube as the volume of solid, remaining solid. Fourth sum. A solid consists of a right circular cone. A solid consists of a right circular cone of height 12 centimeter and radius is 6 centimeter. Standing on a hemisphere of radius 6 centimeter is placed upright in a right circular cylinder full of water. This is the right circular cylinder. It is full of water. When you put any object inside the cylinder, the water comes out. In this question, they are asking the volume of water displayed. Volume of water is displayed out is nothing but the volume of the solid immersed it. Okay. In this sum, the solid immersed it is in the form of hemisphere, consists of a right circular cone. Okay. So we have to find the water displaced amount by adding the volume of cone plus volume of hemisphere. Volume of cone is equal to 1 by 3 pi r squared h. Here the radius is 6, height is 12. V is equal to 1 by 3 pi into 6 into 6 into 12. 4 times. In 3 tables, 4 3s are 12. V is equal to 6 into 6 36, 36 into 4. 6 4s are 24, remaining 2, 3 4s are 12 plus 2 for 144. V is equal to 144 pi centimeter cube is the volume of the cone. Next, volume of the hemisphere. Formula V is equal to 2 by 3 pi r cube. Here the radius is r. 2 by 3 pi into r value 6. 6 cube means 6 into 6 into 6. 2 times 2 2s are 4, 6 6 are 36 into pi. 36 into 4. 6 4s are 24, remaining 2. 3 4s are 12, 12 plus 2, 14. So 144 pi centimeter cube is the volume of the hemisphere. Next, we are finding the volume of water displaced out. Volume of water displaced out is the sum of volume of the cone plus volume of the hemisphere. By adding these two, we get 228 pi. into 22 divided by 7. 288 into 22. 8 2s are 16, remaining 1. 8 2s are 16 plus 1, 17, remaining 1. 2 2s are 4, 4 plus 1, 5. 5 7 6. 6 13, remaining 1, 3 3. 6 3 3 6 divided by 7. 6 3 3 6 divided by 7. 9 7s are 63. 0. 5 7s are 35. Remaining 1. 1 7s are 7. Remaining 1. So remaining 3. 4 7s are 28. Remaining 2. is equal to volume of water displaced, which is equal to 905.14 centimeter cube. Fifth sum. A capsule is in the shape of cylinder with two hemispheres stuck to each of its end. If the height of the entire capsule is 12 mm and diameter of the capsule is 3 mm, how much medicine it can hold? Volume of the, in this sum we have to find the how much medicine it can be hold is nothing but the volume of the capsule. Volume of the capsule is the sum of volume of the cylinder plus volume of two hemisphere. Okay. From this diagram, the radius is, diameter is 3 mm, then the radius r is equal to 3 by 2 mm. R is equal to 3 by 2. Here also 3 by 2, r is equal to 3 by 2. In this length also, height also 3 by 2. Okay. 12 minus 3 by 2, 12 minus 3 by 2 minus 3 by 2, we can get the height of the cylinder h. 12 minus 3 by 2 minus 3 by 2 is equal to 12 minus 3 divided by 2, 1.5. Again 3 divided by 2, 1.5 is equal to 12 minus 1.5 plus 1.5, 3 is equal to 9. So 9 millimeter is the height of the cylinder. Volume of the cylinder formula, V is equal to pi r squared h. Volume of hemisphere, V is equal to 2 pi 3 pi r cube. Volume of one hemisphere. But here we have to find the volume of two hemisphere. So we have to multiply by 2 on both sides. 2v into 2 by 3 into pi r cube is equal to 4 by 3 pi r cube is the volume of two hemisphere. Next, we have to find the volume of the capsule is the sum of volume of cylinder pi r squared h plus volume of two hemisphere 4 by 3 pi r cube. Next sum, step 4 pi r squared h plus 4 by 3 pi. Here we are writing the r cube as r squared into r. Okay, r squared into r is equal to r cube. R squared into r. Take pi r squared outside. Pi r squared into h plus 4 by 3 into r. Pi value 22 divided by 7. R value 3 by 2 into 3 by 2. H is nothing but the height of the cylinder is 9. 4 by 3 into R, 3 divided by 2. (22) divided by 7 into 9 by 4 into 9 plus 3 get cancelled. In 2 table it is 2 times 9 plus 2 is equal to V is equal to 22 divided by 7 into 9 into 4 into 11. 9 plus 2, 11 equal to 22 into 9 11s are 99 divided by 7 into 4. In 2 tables 2 times 11 times. We get 11 into 99 divided by 14. 9 into 11, 99, again 99, 9, 8, 1, 10, 0, 8, 9, 10, 0, 8, 9 divided by 14. 1 14s are 14, 2 14s are 28. Here we write down the 14th table. 56, 5 14s are 70, 6 14s are 84, 7 14s are 98. Now we have to divide 1089 by 14. 1089 is divided by 14. 108, 7 times 98, remaining 10. 109 is also 7 times 98, remaining 11 point, again 7 times 98, remaining 12, 120, remaining 22, 1 times 14, remaining 8, 7 times 17, 5 times 17. The volume of the capsule is equal to 77.715 millimeter cube. As shown in the figure, a cubical block of side 7 cm is surmounted by a hemisphere. Find the surface area of the solid. The surface area of the solid is nothing but the sum of total surface area of the cube and curved surface area of the hemisphere is minused by the area of base of hemisphere. Okay. Total surface area of the cube formula 6a squared. In this question, the side is given 7 cm. A value is equal to 7 cm. Then A is the diameter of the halosphere. 7 cm is the diameter of the hemisphere. This is also 7 cm. Then its radius r is equal to 7/2 centimeter. First one, total surface area of the cube is equal to 6 into a squared. 6 into 7 square, 6 into 49. 49 into 6. 6 4s are 9 6 are 54, remaining 5. 4 6 are 24. 24 plus 5, 294. 294 centimeter squared is the total surface area of the cube. Next, curved surface area of the hemisphere formula 2 pi r square. 2 into 22 divided by 7 into r squared. R value here, r is 7/2. 7/2 into 7/2. 7 get cancelled. 2 cancelled. In 2 table 22 is 11 times. Then the curved surface area of hemisphere is 77 centimeter squared. Next one, area of base of the hemisphere. This is the area of base of the hemisphere. Formula pi r square. Pi value 22 divided by 7 into 7/2 into 7 divided by 2. 7 get cancelled. It's 11. 77 divided by 2. 3 times 6. 8 times 16, remaining 1. 5 times 10. 38.5 centimeter squared is the area of the base of the hemisphere. Now we are finding the surface area of the solid is equal to 294 plus 77 minus 38.5. 294 plus 77, 11, remaining 1, 10, 17, remaining 1, 371. 371 minus 38.5. 371 minus 38.5. 5, 2, 3, 3. 332.5 centimeter squared is the surface area of the solid. Next problem. A right circular cylinder is enclosed a sphere of radius r units. A right circular cylinder is enclosed a sphere of r units. Calculate the total surface area of the sphere. First one, you have to find the surface area of the sphere. Formula is 4 pi r squared square units, because r is given in terms of r units. Next one, the curved surface area of the cylinder. Next, second one, we have to find the curved surface area of the cylinder. Here the radius is r unit. Height, we don't know the height value, so we have to find the height. Here the radius is r. Here also r is the radius. From this side up to this is also the radius. The total height is equal to r plus r. Then h is equal to 2r. The CSA of the cylinder formula 2 pi r h, 2 into pi into r into, substitute 2r instead of h, 2r. 2 2s are 4, pi r into r squared, square units is the CSA of the cylinder. Third question, the ratio of the areas obtained in 1 and 2. Ratio of the area. Ratio means divide. Okay. Areas obtained 1 and 2. 1 is surface area of the sphere and 2 the curved surface area of the cylinder. Surface area of the sphere 4 pi r squared. Curved surface area of the cylinder is also 4 pi r squared. Both can be cancelled. We get 1 divided by 1 as the ratio. 1:1 is the ratio of the area.